So, welcome. Here we are in the office of IDbike. We develop electric bicycles and components for bicycles, and we are also manufacturing the sensor of our system. Actually, the heart of our system. In this room, we design the products, the mechanical products, and as you can see, several bicycles are here from customers, but also bikes we use for demonstrating our technology. So, for instance, this is a mountain bike with our technology. This mountain bike has a rear wheel motor with gears, so this motor will provide a lot of torque, and in this bike also a prototype sensor is mounted, which is based on the next generation sensor we already have in production, but it's much smaller. But it only can be used with true axles. That's because it's so tiny, it needs a certain strength around the axle. So this sensor is mounted in this mountain bike, and it's also mounted in a racing bike here. It's the same sensor mounted here. And this new sensor is being developed especially for these kind of bikes, where the weight is very important and where the small dimensions are very important.
Hello.
Yeah, this is Mark. This is our mechanical engineer who develops the new sensors, and he also works on the production line of these sensors, because we want to produce these sensors almost automatic, without any labor necessary to work on it. So this is one of our development rooms, in which we work on prototype bicycles. You can see a lot of different prototype bicycles here with various motor systems. So this is a bike with a direct drive motor again. So especially for developing the system for speed pedelecs. Next to this bike there is a bike with a very small motor, but still very powerful. This motor has gears, so the torque will be higher in a very small package. This is again a bike of one of our customers. It's a Stromer bike, and in this bike we are testing a second generation sensor, especially developed for Stromer. Here are some other bikes with a direct drive motor, and this particular one has a direct drive motor with gears inside the motor, so it doesn't need to have a derailleur. Here's another bike with a direct drive motor, but it's in the front, and this bike also has a belt drive. The belt drive, you see it on more and more bicycles, especially in Europe. It has a lot of advantages. It doesn't wear, it doesn't get filthy, so you don't need a chain case, for instance, to stay. Waar komt dit niet uit? To stay clean, whatever. Also also working on new equipment for the production. One of the machines which is being developed is a machine for automatic mounting of the very small magnet in the magnet holder. So as you can see here, this is the magnet holder with the magnet inserted already. And this machine mounts these very small magnets automatically. Yeah, this is another machine we're developing. This machine is specially made for measuring the magnetic strength of these kind of small magnets. IDbike buys these magnets in China, but the manufacturer cannot measure the magnetic strength of the magnet. So this is the reason we build a new machine, which you can put in a lot of magnets, and with each turn of this wheel, one of the magnets is taken over, measured on a certain position, and we have here a wheel with 8 positions for 8 different magnet strengths. This is a machine which also is used in production already, but this is the machine for further development. We use it for calibrating the sensor units. We will explain later on how it works. Yeah. For this development, of course, we need a lot of different parts for machines, and also to test prototypes in bicycles. And for this reason, you have several prototyping machines. So we use for printing all kind of products we need for development and testing. So, welcome to the electronic development lab of IDbike. In this room we develop new electronics for IDbike, so the controllers, and also we are working on software for e-bikes. So we have several people working on that, because the software of electric bicycles is very important. It's very important because the software determines the feeling of the bike. How does it ride? How does it feel when you sit on this bike and bike around?
So I attached a solid state relay to this Raspberry Pi here, connected it to the power supply, and now I got some code to run it on and off. Just a little test. So that will control the cylinder here and press for the big machine.
I am working on developing a belt tensioner that's seen here. This is attached to the frame, and the belt runs over this wheel. And a veer. What is a veer?
Spring.
A torque spring is inside here to apply a force to the belt, so the belt stays on a constant tension, which will improve the lifespan of it.
So here we are in the test center of IDbike. We do a lot of testing, especially with regard to the sensor units. It's very important that sensor units, of course, will function for a very long time on the bike. And we have here various test rigs to test the sensors. So the first one is used for testing the cabling of the sensor and the controllers. So in the setup, the wiring of the controller is tested, and of course we also test the wiring of the sensor. This is second test rig. We can put very high forces on the sensor plate, so we can completely demolish the sensor. So we can apply forces up to 10,000 newtons, which is equivalent with the weight of a car. So we can test the maximum strength of the sensor with this test rig. This one is more important. This is a test rig simulating the force which is on a bike. So it's an on-off force, because when you pedal, the force will be like this on the pedals. And we simulate the change of force on the sensor plate. And as you can see, we have 2 times the second force and 0 force again. This is simulation of what's happening. So this is the force on the sensor, which varies in between 0 and maximum. And here we can see how many times we have done this already. It's about 8 million times already now, which means that the sensor is almost at the end of the test, because we test up to 10 million cycles. So 10 million, so about 10 million times the force is applied on the sensor, which is equivalent with riding 2 times around the globe, and on a very steep hill, because we are simulating very high forces, which only will happen on a very steep hill. Here we have various test rigs for testing the temperature behavior of the sensors. So with this temperature chamber, we can vary the temperature of the sensor in between -20 and plus 100 degrees. So we can see what's happening if the temperature changes very rapidly. And also we can measure the stability of the sensor. What we want is that independent of the temperature, the output signal of the sensor remains the same. So that's a very important aspect of our sensor, that it's almost independent of the temperature. So this is a test rig of IDbike we use for several reasons. We can put a complete bicycle on this test rig. When we do that, we can drive the crank with this crank motor, simulating the bicyclist pedaling on the bike. And doing that, we can measure the complete characteristics of the bike. So we can measure the efficiency of the bike, we can measure how much kilometers a bike will run, we can measure how powerful the bike is. In this test sub we're testing electric motor. And when we test electric motors, we measure how much power goes into the motor, so which electrical power goes into the motor, and we also can measure the output power of the motor. And by doing that, we can calculate the efficiency, we can measure the maximum torque, and we also can measure the noise of the motor. In this way we can compare various motors very well, so we can advise our customers which motor they have to use for a specific bicycle. So welcome to the kitchen of IDbike. As you can see, we have a very powerful coffee machine. and I'll already invite you to have a coffee with me at IDbike when you're able to come to the Netherlands one time.